Okay, we are back and ready to attempt the SN1 type reactions here, and that will again begin by dribbling in the appropriate amount of the SN1 nucleophile into each test tube. To the test tube on the left, we are going to add the 1-chlorobutane, which should not react under these conditions, and at the moment appears to be a clear and colorless solution, so that's at least promising. Adding a few drops to the secondary chloride, which we would anticipate reacting, potentially, shows no reaction at the moment. I hope you noticed that the instant the drops were hitting the solution that they turned very, very cloudy, and as you can see, there's a substantial amount of white precipitate up here on the edges of the flask that happened almost instantaneously. It is safe to say that the tertiary chloride reacted instantly under the conditions, and though the solution itself is now essentially colorless and clear, there's a huge amount of white precipitate up on the edges of this test tube. So this unambiguously reacted in a hurry. Adding the 1-bromobutane. The primary bromide is very faintly hazy. I don't see any actual precipitate there, but there is a certain haze to it. So much like I did with the tertiary chloride in the SN2 part, I'm now going to add several drops of the SN1 nucleophile as a sort of error checking mechanism. If this is a false positive, we would anticipate the haziness to fade, and it seems either unchanged or very lightly faded, but there's no actual visible precipitate at the moment, so we'll just pause right there. Now it's time to add several drops to the secondary bromide. So 2-bromobutane added to the nucleophile. The initial reaction is similar to that of the primary bromide. It has become cloudy. It has not yet formed a precipitate, just a bit of cloudiness. Although, as I'm agitating this, it appears to be getting possibly cloudier, and it's also possible that I'm starting to see a precipitate form. So now, as an error checking exercise, I will add several more drops of the nucleophilic solution, the SN1 nucleophile, and I think it's safe to say that this actually became hazier, and now, though it may not be visible on camera, I can actually see tiny white precipitate that is coating the inside of the flask, and after I'm done flicking it, comes sliding back down the glass. So in my mind, visible here in real life, I would say that this is now definitely precipitated. Not only is there some haze in there, but I can see visible chunks of solid. Returning now to the primary, I would say that I'm seeing haze and possibly the same sort of behavior as for the secondary. There may be tiny little precipitate, but there's clearly more precipitate in the secondary. The primary bromide does not appear to be doing exactly the same thing, although there is enough haze to make me consider this possibly reactive. Back to the primary chloride and the secondary chloride, those are clear and colorless. And let's go and heat these up. In fact, I won't even bother to heat the secondary bromide because that has unambiguously reacted at room temperature. There's no question whatsoever. There's solid up on the edges of this test tube. Whatever else is true about the primary bromide, it hasn't done that yet, although it is hazy down below. So let's heat this up. We have now heated this for quite some time, and it's unambiguous that the primary bromide has reacted, even though one would argue that is unlikely to take place. It is definitely unreacted in both the secondary chloride and the primary chloride, even after heating. Okay, so summarizing all the data in the table, what you see is that the 1-chlorobutane, which you would expect not to react, didn't either at room temperature or when heated, but somewhat surprisingly, the 2-chlorobutane, which should have reacted, especially when heating, doesn't seem to have reacted either. And so what this is really revealing is how much easier it is for a bromine to leave, both of which reacted, even though, again, the 1-bromobutane really shouldn't have reacted. So the fact that there was a reaction there is kind of bizarre, but it again goes to show just how much leaving groupability depends on the size, and so the bromines are substantially larger than the chlorine and therefore leave much easier. Obviously, the fastest reaction of all was the tertiary chloride, as we would have expected. That was nearly instantaneous. But the 2-bromobutane, even though it was substantially slower, did in fact go at room temperature. So surprises here were that the 1-bromobutane appeared appeared to react, especially when you heated it up, and that the chlorines really didn't. The primary chloride shouldn't have and didn't, and the secondary didn't react either, even though it probably should have. Once again, of course, if I were trying to figure out how this worked, the way to do it would be on larger scale. And so I'll just simply point out that the way all of the rules for these reactions were discovered by Germans and Russians in the early 1900s, late 1800s, that was done largely through larger scale reactions. And so we're pretty confident on large scale that we understand how this works, even if, again, on these sort of smaller scale precipitate forming reactions, it's not entirely clear what we're looking at. And once again, of course, the main reason to do it this way is because we can then get a feel for how this works during a single lab period. And you can learn things like, wow, the bromides are much better leaving groups than the chlorides, especially from this data. And from this data up here, you get that sense as well. But even though some of the details don't make sense, the overall trends do.